The next few lessons are going to focus on doing some math to calculate the amount of energy absorbed or gained under different circumstances. Today, we're going to focus on the calculations for heat of fusion and heat of vaporization. Before we start learning about the heat equations, I want to just practice some very simple algebra that's going to be relevant to the equations we're going to learn. So I want you to solve these three questions going to two places after the decimal. So question one is pretty straightforward. We're just multiplying these two numbers together, and that's going to give us 14.72. Question two, a little less straightforward. We have 5.7 is equal to x times 2.2. Anytime we have x touching, or anytime we have x with another number on the same side, we have to isolate x by getting rid of that other number. When we're multiplying x by a number, to get rid of that number, we divide. So we're going to divide by 2.2, divide the other side by 2.2, and that gives us x is equal to 2.59. Question three is exactly the same steps. It's just the x and the 4.1, the x and the number are switched from what it was in number two, but the math is the same. We divide both sides by 4.1, and we get x is equal to 2.49. And for today's math, that is the extent of the actual math that we'll be doing. The hardest part today is figuring out what numbers and what variables to use where. So please write these terms in your notebook. The first term we're going to learn about, the first calculation, is called heat of fusion. And heat of fusion is a constant that tells you how much energy is required to melt 1 gram of a substance. The heat of vaporization, very similar, it's another constant, and it tells you how much energy is required to vaporize or boil 1 gram of a substance. So it's the same idea for each, it's just heat of fusion is for melting and heat of vaporization is for boiling. And these are our three heat equations. We can find these on our reference tables on the last page. There's three of them. Today we're going to be focusing on these two. And we're focusing on two at a time because they are the exact same equation, just with different constants. One has the heat of fusion, which we represent as HF, and the other has the heat of vaporization, which we represent with HV. So let's look at these equations in action. The first question that we're going to do, I'm going to do this for you so you can see as a model. What is the total amount of heat required to completely melt 347 grams of ice at its melting point? So in the old reference tables, they gave you the heating constants for water. They gave you HF, they gave you HV, they gave you C, which we're going to learn about in our next lesson. But that's no longer on your reference tables. That means that they're going to have to give it to you either in the question or in the cluster. But basically what we're doing is we're using, since we're melting, the heat of fusion equation, which is Q is equal to mHF. We're solving for Q because Q is equal to the amount of heat. So Q is our unknown. Our mass is right here, 347 grams. And our HF is 334 joules per gram to melt water. And when we multiply those two numbers together, we get 115,898 joules. Right? And that's as simple as it can be. So these are some keywords to look for to figure out whether you're using the heat of fusion or the heat of vaporization equations. For heat of fusion, you would be looking for the word melt or the phrase is turning from solid to liquid. And for heat of vaporization, we would use the phrase, or we would look for the terms boiling or vaporizing or turning from liquid to gas. So these are some key terms that can help us figure out which equation to use. Now that you're going to try this one on your own, the question is, what is the total amount of heat required to vaporize 1 gram of water at 100 degrees Celsius and 1 atmosphere? And I gave you the heat of vaporization. It is 2,260 joules per gram. So please solve this now. So the first thing to be aware of is that this 100 degrees Celsius and this 1 atmosphere is not relevant to the question being asked, right? All we need is the mass and the heat of vaporization. Our equation is Q is equal to mHV. We're solving for Q because it's asking what the total amount of heat is. We have 1.00 grams, that's our mass. Our heat of vaporization is 2,260 joules per gram. And this mathematically is super easy. Anytime you multiply a number by 1, it stays its number. So we have 2,260 joules are required to melt 1 gram of ice, or sorry, to vaporize 1 gram of water. I'd like you to try this one now. What is the amount of heat required to melt 43 grams of solid magnesium oxide at its melting point? The heat of fusion is 1.9 times 10 to the third joules per gram. So to solve this equation, first we're seeing the word melt. So that means that we need to use Q is equal to MHF, the heat of fusion equation. So we do Q is equal to MHF. We're solving for Q, solving for the total amount of heat. The mass is given right here, 43 grams. And it tells us the heat of fusion is 1.9 times 10 to the third joules per gram. We multiply that through, and we get 81,700 joules. And for our final question, determine the total amount of heat in joules required to completely vaporize 50 grams, a 50-gram sample of H2O at its boiling point at standard pressure. The heat of vaporization for water is 2,260 joules per gram. Please solve this now. Okay, so we see the word vaporize. That means that we use Q is equal to mHV. So Q equals mHV. We're determining the amount of heat, so that means that Q is unknown. Our mass is given to us as 50 grams, 50.0 G, and our heat of vaporization is given to us as well, 2,260 joules per gram. And when we multiply that through, we get 113,000 joules. And that's our answer. So that's how we do heat of vaporization and heat of fusion questions.